All right, just doing some psychology review here, Saturday Night Fever style. So if I'm right, one goes up, the other goes down, negative correlation. Okay, negative correlation. I think I got it there. I hope you do too. That would be as opposed to the more contemporary dance move, raise the positive correlation roof. Forgive me. But mnemonic devices, a little bit silly. I bet you don't forget them. Mr. Woodard talked quite a bit about correlations in his video, of course. Before we leave correlations, I do want to draw your attention to what are called illusory correlations. Correlations between items that people believe to be true, but haven't really been proven to be true. So my favorite one is the one there in the middle. Do full moons cause a change in behavior? Anecdotally, people will say that this is so very true. And there will be days at school where students are acting up and teachers are a little bit edgy, and somebody will invariably say, there a full moon last night? And there was, and everybody will just attribute all the odd behaviors to the full moon. There's actually been studies done to that, and they've found different results. In any case, you have to be very careful with illusory correlations. When people believe two things are related and they really might not be, and you have to do further studies to find out if they are. Okay. A really funny website is that Spurious Correlations. You can make statistics say whatever you want them to. It's funny, but it's also a little bit scary because if you don't know what you're looking at, you might believe something that's very, very false. Mr. Woodard and I might talk about that particular website in class. All right, I'm going to skip that. So moving on from correlations, we're going to go now to empirical investigations. We're going to go to the scientific method, and we're going to go and look at what constitutes a good experiment. So empirical investigation is when you use your senses and observations to gather data, and now we are going to try to find cause and effect. Mr. Woodard was very clear with correlations. Correlation does not equal causation. Just because two things are correlated does not mean that one causes the other. When we look at the scientific method and experiments, we are moving beyond correlation now, and we're going to start to look at causation. Does one thing cause another thing? So the scientific method is going to be designed, it's a step-by-step process that's designed to isolate those two things if you want to see one causes another, one affects another in a very particular way. And so we want to control biases, we want to control variables that could make it look like one thing's affecting another when it's actually not. Okay, so the first thing we need with the scientific method is to draw a hypothesis. We need a testifiable prediction. And that testifiable prediction must also be falsifiable. It must have what's called a null hypothesis. So if I'm looking at vaccines for COVID-19, my hypothesis is this vaccine will indeed limit the spread of COVID-19 or limit the effects of COVID-19 in an individual. My null hypothesis is simply this vaccine will have absolutely no effect on the individual that is taking it. And hypothesis needs to be testifiable and it needs to be falsifiable. It's one of the reasons it's so hard to argue with conspiracy theories. If somebody thinks and believes wholeheartedly that in 1980 aliens landed in Roswell, New Mexico, and there was a bright light on July 18th, and by golly, that was an alien aircraft, well, it's hard to prove that, number one. But maybe even more dangerous, it's hard to prove that that wasn't an alien aircraft. And so if you can't prove that it wasn't, then that person might continue to believe, by golly, aliens landed in Roswell. And maybe they did. I don't know. I can't prove it. It must be testifiable, must be falsifiable to have a good hypothesis. You must also have operational definitions. If you're going to run an experiment, you better have the definitions of the operations in that experiment very clearly laid out. So, for instance, if you want to look at lack of sleep causing cognitive deficits, what does lack of sleep mean? Does it mean that somebody just didn't sleep well? Or does it mean that you're going to get 8 hours of sleep one night, 6 hours the next night, 4 hours the next night? I've operationally defined what I mean by lack of sleep. What about cognitive deficits? How am I going to operationally define that? Well, maybe it's a 32-question multiple choice test. You have to be very specific with how your experiment is being run, because one of the most important things about experiments is they need to be replicated or be able to be replicated. Maybe 5 years from now, somebody looks at your experiment and they say, I think they missed variables in that initial experiment. So I'm going to rerun that experiment, but I'm going to look at some other variables that might have seeped in. They have to be able to replicate it exactly the way that you did it in order for their experiment to do what they are intending. Independent variable, I'm sure you've all heard it. That's simply the variable that's being manipulated by the experimenter. So if you're looking at how lack of sleep influences cognitive deficits, then the independent variable is going to be lack of sleep. You are going to control how much sleep the subjects in your experiment get. The dependent variable, which we'll talk about in a little bit more detail later, is going to be that cognitive deficit piece. That dependent variable depends on whatever it is that independent variable is. So cognitive deficits depend on what happened with the independent variable. So independent is the one that gets manipulated by the experimenter. Now, controlled variables, you want to, again, we're trying to find cause and effect here. We're saying one thing causes another in a very particular way. So I need a control variable. So if I'm doing a lack of sleep study, I got to be very careful with what the subjects do during the day. What if somebody goes and plays a contact sport, gets a minor concussion? I don't know about it. Well, that could be the cause of cognitive deficits on the test the next day. So I have to be very particular with controlling as many variables as possible so I can do what I can to isolate sleep causing cognitive deficits. Nutrition would be another important one in that. If somebody was going to bed and they drank 8 gallons of soda right before bed, well, they might have the same amount of sleep as the other subjects, but the quality of sleep might be much, much different, and that might be what's causing the cognitive deficits. So we have to control as many variables as possible in order to isolate the two that we're looking at. One of the most important things about experiments is randomization. If you are going to study a particular population, you make sure that the subjects in your study appropriately represent in random fashion that particular population. Easy example. If I'm going to study students at Lewis and Clark High School, say lack of sleep causes cognitive deficits, and my population is students at Lewis and Clark High School, I have to randomly select students in such a way that I have no patterns. I can't stand at the front door and just pick every other person that comes in the door. That's a pattern. It might not seem like that's a pattern, but there could be a reason why every other person is coming through the door. They're coming in that type of sequence. So you can have absolutely no patterns. So pulling names out of hats, random number generators, you need randomization. And when you have your population, you better appropriately sample the entire school. I can't have a study that has 10 students if I want to sample, or if my population is a population of 2,000. 10 is probably too small a number. I have to make sure that I've got students from each of the different classes, freshman, sophomore, junior, senior. I have to make sure that the population is appropriately represented in my study. Once I have my population, then I'm going to randomly assign people to 3 main groups. Easy example is the COVID vaccine experiments. Once I have got, now this is a massive population, obviously, and you're going to have thousands of subjects, but then when I have my thousands of subjects, again, completely randomly, I can have no patterns, I'm going to put my subjects into one of 3 groups. Number 1 is going to be the control group. It gets absolutely no vaccine. The other is going to be the experimental group. It receives the actual vaccine. And then there's going to be a placebo group. They're going to receive something that is an inert substance. It does absolutely nothing to the body. It's water, it's sugar water, whatever it might be. Sugar pills is kind of the famous placebo. Why you have a placebo group is that you want to make sure that you don't have what's called the placebo effect. So let's say you're going to do a study on 5-hour energy drinks, and so you give people the 5-hour energy drinks. Well, you want to give a placebo group just a shot of water, and they think that it's the energy drink. Well, that could lead to a placebo effect. They'll say, "Oh, I've got so much energy, I got so much." and they really don't. They just got some water. So you want to see how the placebo effect can influence your results. All right, I've talked for 10 minutes. Time to hand it over to Mr. Woodard.